Hello and welcome to the Slackware on vlog. In a previous video, my friend and I, Warwick, we stripped down one of the original RiscPCs that was used to build the Slackware ports to ARM over 20 years ago. Well, one of them, this machine here, is completely broken. It's irreparable. But the other one, although it suffered the same ill as the one that still works, in that the battery leaked and spread onto the motherboard. The blast radius of the leak on this one was so severe that it covered too much, it even damaged the RAM. Whereas that one, it was only about a centimetre or so away from where the battery was positioned. So the damage was quite limited. So in the previous video, we didn't have all of the stuff we needed to clean it up. So we just removed the original battery and placed a remote battery in there instead. And then we turned it on to ensure that it still worked. But we couldn't leave it like that because the acid is still on the board, and over time it will just further damage the board, which is further exacerbated when you turn the machine on, you apply power, it just makes it worse. So what I'm going to do here is I'm going to strip the machine down again and then properly clean it, and then hopefully it will still work after I've cleaned it. Well, I hope so. I'm not an expert at doing this stuff, but yeah, I hope it works. Thanks a lot for your support for the project. It really helps keep the project running, really buying new hardware, not dealing with the really old stuff, but buying the new hardware for the project, keeping it maintained and all that stuff. So thanks a lot. Let's get into it and strip it down and begin the process of cleaning it up. I do have a PowerTech SCSI card in the other machine actually, so I might put that in, but that can be a secondary thing because it's quite easy to add that in afterwards. But first of all, I need to get the machine cleaned and then reconfigured so that RiscOS boots properly, and then we can start enhancing the machine. Although that said, in terms of Linux, I don't think I'm not sure the PowerTech SCSI card even worked in Linux. I mean, I don't think I ever had it. No, because I never had a SCSI hard drive in my machines. I used the SCSI card for tape. I had a DAT drive. Well, I still do have a DAT drive actually. I just yeah, I could connect up a DAT drive, but then it's nothing to do with this. It's nothing to do with Slackware running on ARM. So what do I need to do now? Remove that. Move the back plane. There we go. So that's the back plane. That's the Acorn Computer 4-way back plane that you plug your expansion boards into. It's a little bit dusty. Put that over there. So what do we have left? Not much, I don't think. Oh, that needs to be unplugged. So the floppy, this floppy cable. This floppy wire kept falling out when we were disassembling it. Might put some tape on that actually. Some glue would probably suffice, but I don't have any here. So let's put a bit of tape on it instead, try and stop it falling out. Although then it's probably not gonna, how far does it might be okay. Let's put it on there temporarily anyway. Always remove it later. Right, and then, okay, so that's the floppy drive. We definitely need that because we're using that for our configuration tool. Right. And then back down to the board. So the damaged battery was here, but you can see this is where the damage is. Okay, so we now have the motherboard out. Yeah, there's quite a bit of damage there actually. We'll use the white wine vinegar to neutralise the acid that's leaked onto the board. Use the isopropyl alcohol to clean it up, and then also clean it with the distilled water. And then finally we'll use this again to help evaporate and do a final clean. So first of all, we just need to pour ourselves a little bit of white wine vinegar in here. If we look here, there's a bit of damage just here, there, from there's a cat coming as well that wants to. No, don't, no, Pulbs, no! We'll start by cleaning this area here It's actually on the back, it's not too bad. I've seen other people's boards where it's much worse. I'm not hearing any corrosion sounds either, so that's always good. Okay, so what I'll do now is use a little bit of isopropyl alcohol. Oh, pop the lid out there. Back in. Right. Just put a tiny amount. We don't need, this stuff evaporates really quickly as well, so let's take a different Q-tip here. Okay. Okay. Okay, and now I've got this is my distilled water here, so we'll do that in there. Okay. Okay, so we now need to clean the top of the motherboard, the white wine vinegar. Just douse that in this and see what happens. And I can see it fizzing here. Yeah, it's not too bad actually. It's not as bad as I thought it would be, but yeah, if this wasn't cleaned, it would just eventually make it worse, particularly as I turned it on. Because when you power it on, it accelerates the electrical charge running through here, accelerates the corrosion. Ooh, have to be careful with that. That looks loose. Okay. I didn't see anywhere else that it's gone actually. Yeah, okay. So that's that done. Now I'm going to use a bit of distilled water to rinse it down. I've seen people dunking the entire motherboard in water. Can't say I'll be doing that. Let's clean that from under there. Okay, and switch the end around. Let's get some fresh distilled water. That's the distilled water all applied. So I'm just going to apply some final isopropyl alcohol just to clean it up a little bit more. This definitely isn't something I would have been doing back in the day, I tell you. But given that it's going to die eventually if I don't take care of it now anyway. And it is always nice to be able to play around with your old stuff. Okay, I think that's pretty much cleaned. Might give it one little last clean off with the distilled water. Okay, so that's the cleanup operation completed. I'm just going to give it a quick dry off with a hairdryer at a distance, just to evaporate any of the remaining distilled water that might be there. And then we need to leave it for a few days to fully dry, and then we'll plug it back in, power it on, and hope that it still works. Okay, so it's all dried off now, and it kind of looks okay. Well, yeah, it's one way to find out. So we're going to reassemble it now and orient this like that, I think. Yeah, very good. There we go. There is actually a screw hole here, but I don't know what I did with the screw. Oh, here, what is it? That could be it. Actually, that probably is it. I'm not sure it is actually. I mean, not that it really needs this screw, because it seems to be quite well secured even with the plastic clips, but oh, well, okay, it seems to be the screw. Well, it screws in anyway. Right, there we go. So yeah, so let's pop that power supply back in. Oh, actually no, I think that screw was to secure the power supply, not which really does need a screw. Okay, well, okay, I'm going to have to find a screw for that. Right, I think that goes up that way around. Okay, seems good enough. Okay, so let's seat the RAM. So we've got two 64 meg sims here. I think normally you pop them that way and just sit them back. Oh yeah, that's it, simple as that. Okay. Haven't done this for so long that I've forgotten what it feels like to seat RAM. I thought it slotted in more, you know, more firmly, but it doesn't. Okay, so let's start connecting these up. So this is the floppy cable, and that plugs in there. I colour coded the connectors on the board so I could remember what plugged in where. Ah yes, I haven't put anything on the internal one, but actually I want to use that to access the CD-ROM. Okay, so I need to go and find myself a spare IDE cable. But then again, actually, have I got enough? Do I even have enough power for the IDE? Have the power connectors for the IDE drive? No, I don't actually. But then again, I suppose I could put. No, I need a power doubler. What I've decided to do, because there's not a huge number, well, it's actually only what, 3 of these types of connectors, and I need one for the CD drive because I need to. I think I need to fix RiscOS by loading some of the original setup tools, like the bootware and all that kind of stuff, off a CD. Because I really can't remember how to do it. I mean, I've looked online and so on, but I've got all of that stuff, so I just need to put it on a CD. But that means I need a CD drive working to do that. And the problem is this one isn't going to reach. That's for powering a disk that lives there. So the only one I can use is this, and then that leaves me with one, but I've got 2 hard disks. I have loads of these connectors. Oh, actually, that's a thought. I probably still do. But yeah, because I've got one here. So this here, this male connector converts into SATA to power SATA disks. But I don't really want to cut that. Although then again, I don't have any x86s that I'd use this for, to be honest. But I'll figure that out later. But anyway, I've got all of the right stuff to do it with. If I need to cut it, I'll cut it. But I won't do that until I know it actually works, because I can easily do it from this one. So I found myself an IDE cable for the CD drive. So I think we'll just plug probably that one in here, which looks like it goes this way around. Okay, so that's the onboard IDE that we'll use for the CD drive. I need to find a screw, replacement screw for that. So let's put the back plane in. I think that's, yeah, that makes sense, I think, to put that in. Yeah, do that now, I think. Okay. Okay, so we'll put the CPU in now. Okay. Then we'll put the network card. This is the iCubed, isn't it? The iCubed network card. So this is Ethernet and 10 base T. Right, that's in. I think that's everything. Yeah. So Okay, so I just need to find a screw for that. Okay, so I found a screw from a PC case. I really hope this still works, actually, otherwise all of this is in vain. Right. Okay, now it's better. Right, good. Okay, so that's the RAM, the backplane, CPU. Anything else? No. I need to assemble the first slice, as they're called. That's floppy, so I need the floppy up here. Ooh, hold on, that's interesting. So I think obviously I did this. I must have chopped it years ago. So actually, oh, that's a good thought. I didn't realise I'd done that. Yeah, I didn't notice that. Oh, it doesn't matter. I'll do it again. I was just thinking I could tap into this terminal block actually and splice it in. But it doesn't matter. I'll do it up here. It's easier. I can solder that in. I'll splice it in later. The last slice, the third slice. Yeah, that's fine. So pop that on like that. At the moment, I don't need the discs plugged in for the thing to boot, so that's good. Okay, so that's reassembled. Let's pop the lid on it and see if we can boot it. I really hope that we can. And then this one on that side. Okay, done. Okay, so it's the moment of truth. I've got the monitor connected, power's connected, so let's see if it still works. Okay. Okay, there's a flashing cursor. Okay, that's fine. I've seen that before. Right. So you can see there, unknown interface. I've seen that actually. I think I saw that in even one of the previous videos. So what I'm going to do is just turn it off. But it turns on, so that's a good start. What we do now is hold down delete. I should use my foot to turn it on. When you hold down delete, you turn it on, it resets all the CMOS settings. So, is it delete? Yeah, it's delete. There's a few different ways of doing it actually. There we go. Oh, nice! Okay, it actually works. So if we press cancel, nice. Okay, so the machine has been cleaned up and it still powers on and boots. So the next thing to do is to connect the hard drives, the 2 disks, and I need to wire in an additional power connector. So I need to splice that one. So I'll do that next. I was hoping to use some terminal blocks just to save me doing some soldering, but I can't find any. I've got loads of terminal blocks, but I don't know where they are. But still, I've got these instead, so we can just still make a good job of it. Now, fortunately, one of the things I like to do is save lots of material as possible. So in this case, I had a bunch of x86s that I binned ages ago, and I cut. I didn't need the power supplies, or they were broken. So if the power supplies work, I tend to save them for the ARM projects. But in this case, I've saved the power connectors off a really old ATX power supply. So all I need to do, I've got like more than we need. I've even got a spare floppy one actually. But also all I need to do is just cut these down and, or rather trim off the end, and then splice them onto the one inside the RiscPC. Done. Right, I think we're done with that. So let's just get the sheaths over the top. We're now in a position to connect the power cables back in. Yeah, we don't need to worry about master-slave setup here because they're actually going to be on different data buses. Put the lid back on. Just one final check, make sure everything's good. Looks good to me. Perfect. Okay. The discs are now powered, well, they're connected to the power. So let's turn it on again. You should hear the discs spinning. Oh, and we've got the we've got the CD drive, which is good. There's nothing in it, but that's good. I can burn a copy of the RiscOS stuff onto it. Ah, nice. Okay, that's good. Cancel. Okay, cool. Now, if you saw the previous video where my friend Warwick and I replaced the battery, one of the discs had the click of death, but I don't hear it this time. You can... Yeah, I mean, so that seems okay actually. So this is stalling booting, it's just waiting for stuff to time out, but so that's not a problem. I might be able to press escape actually to no, I can't. I'll probably press control break. Actually, that's not a bad idea. Let's try control and break. Here we go. And press shift. Hold down shift, because on RiscOS, holding shift down prevents it from running the boot sequence. Perfect. Yes, it did. Right. Okay, so if we open Rapier, okay. Auto install. Hopefully that finds our 2 hard drives. Okay, whatever. Right, then if we do Task Manager, ATA, so we change to the ATAFS file system, which is a third-party filer open. So the ATAFS ATAFS is a third-party IDE card, the yellow one that you might have seen. Open dir string, although I don't know which disk I'm on actually. Yeah, okay. I don't know. Now this is going to complain. Yeah, okay. So that's what I need to figure out. So, okay, but for the time being, that's good. So I'm going to work on that. Okay, so that's really good news because one of the original StrongARM RiscPCs for the Slackware ARM project is now in a good condition, in a stable condition. The acid that leaked from the battery has been cleaned up, so that's no longer, the machine's no longer at risk of further damage, and it still boots. After all the cleanup work, I was confident about it, but I wasn't entirely sure. So that's really good. It still boots. All I need to do now is just get RiscOS back on the rails again and properly configured so that it boots off the hard drive and everything is set up properly, because I think that's why Linux won't boot, because the system isn't set up properly. It doesn't have all of the libraries loaded and all that kind of stuff. So I'll look into that. I know I'm pretty proficient with RiscOS, or at least I was 25 years ago. So I just have to look online for the things that I can't remember. But I'm really pleased about that. And so in a subsequent video, I'll boot Slackware on here and show you Slackware from 20 odd years ago on one of the original build machines. Thanks again for all of your support. I really appreciate it. It helps keep this project running. And take care, and I'll see you in the next video.